Chapter 8. Algorithms. Objectives. After reading this chapter, the reader should be able to understand the concept of an algorithm, define and use the three constructs for developing algorithms: sequence, decision, and repetition. Understand and use three tools to represent algorithms: flowchart, pseudocode, and structure chart. Understand the concept of modularity and subalgorithms. List and comprehend common algorithms. 8.1. Concept. Informal definition of an algorithm. Used in a computer. Input data. Output data. An algorithm is independent of the computer system. Finding the largest integer among 5 integers. The algorithm should be general and not dependent on hash of integers. Refinement. Generalization. 8.2. Three constructs. Three constructs. 8.3. Algorithm. Representation. Flowcharts for three constructs. Flowchart, a pictorial representation of an algorithm. Pseudocode for three constructs. Pseudocode to English-like representation of an algorithm. Write an algorithm in pseudocode that finds the average of two numbers. Example 1. Write an algorithm in pseudocode that finds the average of two numbers. Solution. See Algorithm 8.1 on the next slide. Algorithm 8.1, average of two input, two numbers. Add the two numbers. Divide the result by 2. Return the result by step 2. And write an algorithm to change a numeric grade to a pass/no pass grade. Example 2. Write an algorithm to change a numeric grade to a pass/no pass grade. Solution. See Algorithm 8.2 on the next slide. Algorithm 8.2, pass/no pass grade. Pass/no pass grade input, 1 number. If the number is greater than or equal to 70, then 1.1 set the grade to pass. Else 1.2 set the grade to no pass. And if, return the grade. And write an algorithm to change a numeric grade to a letter grade. Example 3. Write an algorithm to change a numeric grade to a letter grade. Solution. See Algorithm 8.3 on the next slide. Algorithm 8.3, letter grade input, 1 number. 1. If the number is between 90 and 100, inclusive, then 1.1 set the grade to A. And if 2. If the number is between 80 and 89, inclusive, then 2.1 set the grade to B. Continues on the next slide. Letter grade, continued. Algorithm 8.3. Letter grade, continued. 3. If the number is between 70 and 79, inclusive, then 3.1 set the grade to C. And if 4. If the number is between 60 and 69, inclusive, then 4.1 set the grade to D. Continues on the next slide. Letter grade, continued. Algorithm 8.3. Letter grade, continued. 5. If the number is less than 60, then 5.1 set the grade to F. And if 6. Return the grade. And see Algorithm 8.4 on the next slide. Example 4. Write an algorithm to find the largest of a set of numbers. You do not know the number of numbers. Solution. See Algorithm 8.4 on the next slide. Algorithm 8.4, find largest. Input, a list of positive integers. set largest to 0. While, more integers, 2.1 if, the integer is greater than largest, then 2.1.1 set largest to the value of the integer and if and while, return largest. And write an algorithm to find the largest of 1000 numbers. Example 5. Write an algorithm to find the largest of 1000 numbers. Solution. See Algorithm 8.5 on the next slide. Algorithm 8.5, find largest of 1000 numbers. Find largest. Input, 1000 positive integers. Set largest to 0. Set counter to 0. While, counter less than 1000, 3.1 if, the integer is greater than largest, then 3.1.1 set largest to the value of the integer and if 3.2 increment counter and while, return largest. And 8.4. More formal. Definition. Algorithm. An ordered set of unambiguous steps that produces a result and terminates in a finite time. A well-defined, ordered set of instructions. Each step, clear and unambiguous. Result, return to the calling algorithm or some other effect. Must terminate. 8.5. Subalgorithms. Subalgorithm. The principles of structured programming require that an algorithm be broken into small units, subalgorithms, subprograms, subroutines, procedures, functions, methods, and modules. Each subalgorithm is in turn divided into smaller subalgorithms. The process continues until the subalgorithms become understood immediately. Concept of a subalgorithm. Algorithm 8.6, find largest. Find largest. Input, a list of positive integers. Set largest to 0. While, more integers, 2.1 find larger and while, return largest. And, subalgorithm, find larger. Find larger. Input, largest and current integer. If the integer is greater than largest, then 1.1 set largest to the value of the integer and if and 8.6. Basic algorithms. Figure 8.10. Summation. Figure 8.11. Product. Sorting data are arranged according to their values. One of the most common applications in computer science. Selection sort. Bubble sort. Insertion sort. Selection sort. A list of n elements requires n1 sort passes. Figure 8.12. Selection sort. A list of n elements requires n1 sort passes. In pass k. Example of selection sort. Figure 8.13, Part 1. Example of selection sort. Example of selection sort. Figure 8.13, Part 2. Example of selection sort. Figure 8.14. Selection sort. Algorithm. Bubble sort. A list of n elements requires up to n1 passes. Figure 8.15. Bubble sort. A list of n elements requires up to n1 passes. The smallest element is bubbled from the unsorted sublist and moved to the sorted sublist. Figure 8.16, Part 1. Example of bubble sort. Figure 8.16, Part 2. Example of bubble sort. Figure 8.17. Insertion sort. A list of n elements requires n1 passes. Example of insertion sort. Figure 8.18, Part 1. Example of insertion sort. Example of insertion sort. Figure 8.18, Part 2. Example of insertion sort. Searching. Find the location of a target among a list of objects. One of the most common applications in computer science. Sequential search used if the list being searched is not ordered. Binary search. Figure 8.19. Search concept. Example of a sequential sort. Figure 8.20, Part 1. Example of a sequential sort. Example of a sequential sort. Figure 8.20, Part 2. Example of a sequential sort. Example of a binary search. Figure 8.21, 8.7. Recursion. Recursion. Iteration. Recursion, a process in which an algorithm calls itself. Iterative definition of factorial. Figure 8.22. Iterative definition of factorial. Recursive definition of factorial. Figure 8.23. Recursive definition of factorial. Tracing recursive solution to factorial problem. Figure 8.24. Tracing recursive solution to factorial problem. Algorithm 8.7, Iterative factorial. Input, a positive integer num. Set facton to 1, facton equals 1. Set I to 1, I equals 1. While I is less than or equal to num, I less than equals num. 3.1 Set facton to facton xi, facton equals facton I. 3.2 Increment I equals I plus 1, and while. Return facton. End.